The last article of a syllabus, that is a simplex method. Uh, we are going to see one example, which is a very simple example that we already seen in a formulation. That we started with this example only, where a dealer wants to sell two articles A and B. He is earning rupees 2 and 3 on one piece of A and B respectively. He buys these articles for 1 and 2 rupees, and he can invest only 100 rupees there. 100 rupees. We have to formulate the LPP to get the maximum profit there. Okay, maximum profit. So that is the question that we have. So this formulation we already seen. So we know already that LPP is like we have to maximize 2x1 plus 3x2 subject to the only one condition, x1 plus 2x2 less than or equal to 100, and obviously the number of articles should be the positive. So this is non-negative restriction. So these three things are always there in every LPP. We already seen the graphical method. Let me complete the solution quickly by graphical method. The reason behind it is the simplex method is related to the graphical method only. Only the graphical method have a drawback that it only works up to the two variable, but simplex method can work for two variable or more than two variables also. So because of that, the simplex method is a more popular method there, because in general in many cases we have more than two variables in the LPP, and because of that we have to solve it by a simplex method only there. So to get a solution, the non-negative restriction already indicates that this solution exists in a first quadrant. So first of all, we should have that x and y axis. Let I draw here, say this is my x axis. In the exam, yes, you have to draw the rough sketch, that is enough there. Let us assume this one is our y axis there. So we have this x and y axis. Now, our aim is to draw this inequality. To draw the inequality, first convert that inequality to the equation. So we have that equation. I will write that equation as x1 plus 2x2 equal to 100. Equal to 100. So this straight line we have to draw it. And to draw any straight line, we require minimum 2 points. So if we put x2 equal to 0, we get x1 as 100. So let us say this is my 50 unit and this is my 100 unit. So we got the point 100, comma 0. So this is the point on x-axis there. Now if we put x1 as a 0, we get x2 as a 50. So let I say this is my point 0, comma 50. So we have now a straight line, or we want to draw a straight line which passes through these 2 points. So let I draw that straight line here. This is the straight line. Now once we draw a straight line, this straight line divides the first quadrant in two parts. First part is this triangle and the other part is this unbounded region. But right now we use the test of origin. So to check the region, if we replace the origin coordinates as a 0, 0, 0 is less than 100, and that is a true. That means 0 is satisfying our constraint. So region is a towards origin. Okay, so this way we decide generally the region of integration. So then we'll highlight that region, highlight the region of integration. So this one is our region of integration. You can shade it by, okay, this shaded region, this triangle, this is our the feasible region. This region is known as a feasible region. Feasible region. Now the meaning of the feasible region is all these points satisfies, all these points of this triangle satisfies the problem. That means these are possible solutions of LPP, but our aim is to get a best solution. That best solution always occur at one of the corner point of the feasible region. Right now this triangle have three corner points, say 0, 0, 0, 0, 100, 0 and 0, 50. So these are the three corner points. So if we give the names to that corners O, A and B, what is our aim? Our aim is to calculate the value of Z at these three corners first, and then we can say we can compare these values and we get a maximum there. What is our Z? The formula for Z is a 2x1 plus 3x2. So let I write here the value of Z as a 2x1 plus 3x2, and we say the points. So points are O, A, and B. So say O is a 0, 0. Point B is a 0, 50, and A is a 100, comma 0. So Z equal to, this one is a 0 here. In this case, it is a 200, because we are replacing 100 into 2. So, but 150. So just we have to compare all these values, and we get here only one maximum. Generally, sometimes we are getting the maximum at more than one point. In such a case, we say there are infinite solutions, but right now the case is we have that a unique solution here. So just we have to mention, we can highlight here, this is the coordinate where the z becomes a maximum. We can say thus maximum z, maximum value of a z, maximum value of a z is 200 at 100 comma 0. So this is the end of graphical method. This way you can complete in the exam also. What are the things you should write in the exam? The first thing, that your graph should be the correct graph. You should highlight the correct feasible region. Okay, then only you will get the marks for the graph. Next, you have to make this table of values of z at each corner point, and then you have to compare, and by comparing you get the maximum value of the objective function there. Okay, so that about the graphical. Now let we come to our last article. This last article is a simplex method. Okay,
Sir,
before
if we get more than one maximum value,
then we say more than one maximum means maximum value should be only one, that is a 200. Okay, it may happen that 200 you will get at the point A as well as at the point B, and then you can say we have a maximum value on the line segment AB. Got it?
yes, sir.
Okay, so maximum value is always a unique value, is unique, but it can occur at more than one points. That is the difference. Okay, we'll already discuss that. So this one is a graphical method. Any doubt in the graphical method? Anyone?
No doubt.
No doubt.
No,
Okay.
sir.
So what is now last method? The simplex method. Simplex method always starts with origin. In simplex method, first we always get one feasible solution. We start with a feasible solution as a 0, 0. 0, 0 is one of the feasible solution, is it? Because 0 is less than 100. This x1 and x2 are zeros, and z is also 0. So this is the 0, 0 is one of the feasible solution. That is one of the possible solution. So we start with that solution, and then the simplex algorithm is like that. It moves from one corner to other corner. For example, we may move from origin to point A or origin to the point B. Okay, so if we move from origin to the point A, right now, yes, the coefficient of x2 is a larger. Yes, we will move from origin to A and then A to B, and we get the answer in two iteration, probably in two iteration or one iteration. So it is iterative method. It is iterative method, but number of iterations will be the always less than or equal to the number of vertices of vertices of that polygon. Right now, how many vertices for this polygon? There are 3 vertices. So origin is initial table. We may have 1 or 2 iteration. So maximum 2 iteration will be there to get the required answer. You may get the answer less than or equal to 2 iteration. That may be that you may get answer in first iteration also. Okay, it depends. So we'll come to the simplex method. Now how simplex method starts. So I'll require,
Sir, iteration means.
pardon?
Sir, iteration means.
Iterations mean it is a repetitive process that you have to do it again and again to get a correct answer there. Okay, or required answer. So we'll come to that part also. Now theory, or whatever the theory I will tell you in words, all this theory is already on that PDF, which PDF is already attached on TMI LMS portal there. Okay, so I think all you should download it there, and you can read the theory first, then it becomes more clear to you. Okay, so I'm taken this problem again here, because I want to tell you what are the things that you have to do it for the simplex method there. Actually, sorry, just a minute. Why that dotted are coming here, I don't know. Just a minute only. Okay, whatever. Okay, so come to the simplex method here. Step one of a simplex method, that is, we have to write the LPP in a standard form. Now, what is that standard form? First of all, the objective function will try to keep it as a maximize only. We can solve it for minimize way also, but I will suggest you to keep uniform algorithm of a simplex. Always keep the objective function as a maximize only. If it is minimize, how to deal with that, we'll see in the next class, in the next example. Okay, right now just I will say already it is a maximize type, so I will say the objective function is here. uh, this is, I'm writing here step one. Okay, this is the step number one, that is known as a standard form. This is a standard form of simplex that we have to do it in the step one. What is the standard form? That objective function should be maximize only. So maximize z, that is already there, 2x1 plus 3x2, subject to. Now subject to the condition. Now we have to start with the condition. So each condition we have to write in the equation form by adding the slack variable. Now what is a slack variable? You will observe sum of these x1 plus 2x2 is a less than 100. So there is something less in left hand side. So we should add something, add some positive number. If you add some positive number, let we assume that is s1. If you add s1 in the left hand side, it comes equal to the 100 that we are assuming, and that s1 is known as a slack variable. So you can give the name as s1, s2, s3, so on. So right now only one constraint is there, so we'll add that x1 plus 2x2 plus s1 plus s1 is equal to 100. Now what happened here, because of that adding s1, we converted that less than to the equal only. Okay, so the s1 is some slack that were filled up by the variable s1, and so the name is known as name is given as a slack variable here. And obviously the last thing, non-negative restriction, all variables say x1, x2, s1 are positive. They are only positive, and because of that it is possible that x1 plus 2x2 equal to 100. Okay, so and one more thing that we have to give it, we have to give the zero coefficient to this variable to the objective function. Why this is? Because we already know the value of z depends on x1 and x2 only from the given question, and it is not a function of s1, so we can give a zero coefficient to that variable in the objective function. This is the end of the standard form. So what are the important things that we have to do in the standard form? The first thing, objective function keep as it is if it is a maximize. Then just add a slack variable to each constraint of a less than type. Add slack variable to each constraint of a less than type, so that is plus s1. And now and non-negative restriction. Any doubt in writing a standard form? Is there any doubt in writing a standard form?
No, sir.
No doubt. Okay, very
Sir,
good.
we can also define the slack variable also
No need to
after
write
putting that
anything about,
condition.
no need to write anything about the algorithm. What is a slack variable, or what is the what we are doing? So no need to write it. All this is a theory part, and that theory part you will find on that PDF. Okay. So in the exam, whatever we are doing right now, that way only you have to do it. So in the exam, you will
Excuse me,
write
sir.
step one standard form, and you write only these three things there. Okay. And now we'll start a solution here. Iteration table. Yes. Any doubt?
Considering non-negative decision variable, sir, x1, x2 will be greater than or equal to 0, or would be simply equal to 0?
No, greater than or equal to 0. No, they are not zero. Already you will observe that is already they are greater than or equal to 0. Is it in the given problem only?
But
This
when
S1
we
is
are
also greater
adding
than
this
or yeah.
flag, then it will
Yes, Parth.
when we are adding slack, then also it will be greater than or equal to
Obviously,
0.
because x1 and x2 will not change. They are as it is. Na. Suppose यहाँ होता 5. हाँ, 5 plus 2 into 5. So what is that? So this is 15. So that S1 should be then 85. Okay, then it is 100. So that way. Already x1 and x2 are positive, that's given. Na? So that can be any positive number.
Sir, slack value should be greater than 0, na?
Yes, obviously, if it is a negative, suppose S1 is suppose minus 10. So already x1 plus x2 is less than 100. And if you take minus 10 there, then is it become equal to 100 then? Can it become equal to 100? No, no.
No.
So it should be greater than. Then only it become equality. Why we are taken that is equal there? Okay. So the problem becomes now, this is our standard form of LPP. Now from this only we are going to start with one feasible solution. What is that feasible solution? We are going to say, let us say x1 and x2 are 0. x1, x2 are 0. So s1 is 100. S1 is 100. So what is the value of z? Z is also 100 there. And that is known as
Yes.
feasible, one feasible solution. Sir, will there be any choice to solve it by graphical method or simplest form? No. Okay, so Sayam is asking, can we solve this problem by graphical in the exam? If in the question, if in the exam the question is solve the following LPP by a simplex method, compulsory you have to solve it by simplex method. If you solve it by graphical method, you will not get a marks there. Okay, so the question comes for 5 mark, and you should complete by a
Sir,
simplex.
mostly simplest method is that asked or graphical.
Graphical method is obviously a simple. Graphical method is a simple method, but when the problem have more than two variable, you don't have option of a graphical method. Only simplex method will work. In this case, yes, both methods are working because two variables are there. Okay,
Yes, sir.
so let me start a table now. Now we'll start a table as a we have to, the table starts. This is known as the initial table. This step 2, I will say. Step 2, initial table. Initial table starts with the cost values. Now remember, which are the what is the standard form? The standard form is maximize z is equal to cj xj. The cj's are these values 230. These are cost values there. Okay, so I will use one word, say cj. Okay, this cj I am writing here. They are the cost values. Cost values in the objective function. And what are that? 230. So I will write that cost values as a 230. So the first row of the table is always a cj. Next row is we have to write down the corresponding variable. 2 is a coefficient of x1, 2x1 plus 3x2 plus 0s1. That is the variables present in the objective function. Okay. Now we have to write down below that. Below that we have to write. Below that we have to write the constraints there. So to write that constraint, this constraint, I will take, this is like aij equal to bj. So I'll take here as a bj. This is bj. Bj's are constant on RHS. Now write the coefficients of that below it. What is there? 1x1. So I'll write 1x1, 2x2, 1s1 equal to 100. So whatever all the constraints you have, just write below that variable. Okay, right now only one constraint is there. So only one equation come here. This 1x1 plus 2x2 plus 1s1 plus 100. Okay, or equal to 100, sorry. That one. After that, the word comes like a basis. The basis is a word that you have to write, and that basis is nothing but this is a variable. This is the variable which form the identity matrix in that constraint form. Right now there is only one constraint, so right now that x1 also form the identity matrix, s1 also form, because it is one number only. But generally that slack variable are always a basis. They are always a basis. They are always a basis. You can take x1 also as a basis. Are you getting? Right? Sometimes you have a choice. In this is only the case where you have the choice, because only one constraint is there. So you can take s1 as a basis or x1 also as a basis. Which one you want? Both are the choice, because right now their coefficients are 1 in that equation and 0 in the other. Actually other equations are not there. So right now both can be the basis variable. So let I say s1 initial table, that slack variable take always as a basis. What is the corresponding Cj? Cj of that basis variable. This Cj of s1 is a 0. This Cj of s1 is here also, you have to write as 0. So this is one more column we added. Yes, method, you may think it is a very difficult thing, but after completing one example, I know once we finish one example, and if I give you next example, 60 to 70% of the student can do it their own. And once we finish two example, all of you can do that these examples your own, because this is a repetitive method. Initial table only important. Whatever the table we are making, this table you have to repeat again and again. That's one only. Okay, so that about the first three rows.
So once again, can you please explain
Yes,
initial table?
I am going to explain it again with the next table and again and again. So, or you can go through the recorded video later on. Okay. So right now, just follow it. If you're not getting, don't worry. You can get in the next question only. Okay. So once you write this, the equation of constraint, now the next row we have to prepare. The name of that row is a ZJ. This ZJ, the name is given as an inner product or dot product of the vector. Now, which are the vectors here? Cj is one vector and this xj's are another vector. Like Cj is right now vector of only one entry, like Cj dot x1. If you take Cj dot x1, 0 into 1 is a 0, 0 into 2 is a 0, 0 into 1 is a 0. So in initial table, zj's are always a 0, because the cost values of slack variables are always a 0 there. Okay, they are 0. So when you take a dot product with a 0 vector, the zj's are 0 in initial table, but later on they will change. We'll come to that also. Once you get a zj, now there is a last row of the table, and that last row is known as a cj minus zj. Cj minus zj. Now this is the important row, because this is the row known as the stopping criteria of the iteration. So when we calculate this Cj minus Zj, this mainly indicates, is there a scope of improvement? This actually indicates, is there a chance to improve our solution that decided by this one. So let me calculate it first. This is a 2, Cj minus Zj, C1 minus Z1 is a 2, C2 minus Z2 is also 3, and C3 minus Z3 is 0 itself. So if this value is coming positive, I will come to that part. If this value Cj minus Zj comes a positive, that indicates, this indicates there is a chance, to improve, the solution. And what is that chance? You will observe the maximum value, maximum positive value. I will write it here. Max positive value is known as incoming variable. Now new definition is there. It's an incoming variable. So this x2 is coming in, so you have to show like this. How we decided incoming variable? You have to just check maximum positive value of Cj minus Zj, that is incoming, If all values are less than or equal to 0, we say we stop the iteration and we get a maximum value. We get a maximum value of z there. Okay, but right now there is no maximum value of z. Now for this table, if some variable is incoming, where it is incoming? Actually, it is coming in the basis. This x2 should come in the basis to get a better solution. Means if x2 comes in the basis, that variable from the basis should go out. To decide outgoing variable, the term is known as a ratio. This is the last column of the table, and we take bj divided by that incoming variable bj upon x2. Now if we take 100 upon x2 coefficient, 100 by 2 is a 50. We have to take minimum positive ratio as outgoing. In this case, only one ratio is there, and that is positive also. So corresponding variable will go out. This is going out. This is outgoing variable. So that is the end of the table 1. I know many of you are not getting and many of have the doubts. Don't ask right now anything. Let I finish first, and after that I will come to the doubts there. So we get here,
Reason behind in
just 1
putting
minute, what
the
I said. So here we have this x2 as incoming variable and s1 as outgoing variable. So the rules of incoming and outgoing variable you should remember. Maximum positive value of Cj minus Zj is incoming and minimum positive ratio is outgoing, but right now the ratio is only 1, so there is no comparative value there. Because of that, whatever the positive ratio is there, that we taken as a outgoing there. Once we get incoming and outgoing variable, the this intersection of this incoming column and outgoing row is known as a pivot element. So in this case, this 2 is known as a pivot. This is a pivot element. So for this pivot, now we have to use that elementary row operation that you are going to learn in matrices. We have to make the pivot as a 1 and the other entries in that column as a 0. In this case, only one row is there. So just we have to make the pivot as a 1 so that that variable becomes a basis variable. So I will come to here, that is only one row is there. This is the middle row is important. So I will say here this is the first iteration. Now we are starting the first iteration. It is step 3. I will say step 3, first iteration. Now for this first iteration, what is always our aim? Make the pivot as 1. So suppose we denote this row by r1. So I will say by r1 divided by 2, and that becomes a 1 there. So our aim is to make just a pivot as a 1. So this is only transformation we are going to do it on this row. So what will become? The Cj's will be as it is. In initially, whatever the Cj's we have, like 2, 3, 0. After that, we have the variables x1, x2, s1, and then bj. Now, whatever the row we have, this row, we are dividing by 2. So it is 1 by 2, 1, and again 1 by 2. So you'll get 1 by 2 because we divided by that row by 2. Here is 1, and this is also 1 by 2. And this is becomes a 50 then. This become 50 because 100 upon 2. So this is the r1 upon 2. We done just r1 upon 2. Now we come to the basis. Now basis always changes. Already the basis variable is s1. Why s1 is a basis variable? Because its corresponding coefficient is 1 there. Right now s1 goes out from the basis. We just written there out for s1 and in for x2. So the place of s1 is taken by x2 because their coefficient of x2 is always 1 then. Okay, because it is in the basis. Now the corresponding cost value. What is the cost value of x2? Cost value of x2 is a 3. That you have to write it in left side. Okay. Now this is the table that we came here. Next row we have to calculate as a zj. That is a dot product. Take c1 into x1. So 3 into 1 by 2 is a 3 by 2. 3 into 1 is a 3. 3 into 1 by 2 is a 3 by 2. And last row is there cj minus zj. Cj minus zj. This is the row which decides whether we have to stop the iteration or we have to continue it. So 2 minus 3 by 2. 2 minus 1.5 is 1.5. So it is 1 by 2 will come. 0 minus 3 by 2. You will observe Cj minus Zj is still positive. Means still we don't have the better solution in this table. So to get that better solution, we have to take maximum positive, max positive as incoming, and in this case max positive is plus 1 by 2. So this variable should in come in the basis. So this is incoming variable. X1 is incoming variable. So if X1 is incoming, that other variable of the basis should go out. And for basis, we calculate a ratio, outgoing variable. So Bj upon X1. In this case, Bj divided by X1. So we take 50 divided by 1 by 2. 50 divided by 1 by 2, it will come 100. So minimum positive ratio is 100. So only that 100 is a ratio, and that should go out. Now this is outgoing variable. This is outgoing variable. So x1 is incoming, x2 is outgoing, and now the pivot becomes 1 by 2. This pivot we have to convert to the 1. This pivot we have to convert the 1. So one more iteration we require. So actually we taken here step 3. Step 3 as a first iteration. I will write here step 4. Step 4. Step 4 as second iteration. This is the second iteration. Now for this second iteration, again we start this table. The first row of the table is always start with the Cj. What are the Cj's? Cj's are always fixed. Say 2, 3, 0. Corresponding variables are like x1, x2, s1 and bj then. Now we have to write that this equation row by that transformation. So what should be a transformation to make it as 1? So we'll say, suppose this name of the row is R1 here. So we should multiply by this row by 2. So by 2 R1, we should say here by 2 R1. So I'm just multiplying this row 1 by 2, and we get again the original coefficient probably, that is 1, 2, 1 to 1. So we get 1, 2, 1, and that 100 because there is 50. Bj is 50, 50 into 2 is 100 there. So that's one. The basis will change now. The basis, original basis is there x2. Now it comes as x1 because x2 goes out. We return here. This x2 is out. This out is written there for x2, and for x1 we return as a in. So place of x2 will taken by x1 there, and x1 is in the basis now. And the corresponding cost value. What is the cost value of x1? Cost value of x1 is 2 there. So we'll write as it is there. We calculate Zj then. Zj is a dot product. 2 into 1 is a 2. 2 into 2 is a 4. 2 into 1 is a 2. That's one. And lastly, then we have this Cj minus Zj. So Cj minus Zj, you will observe 0. This is a minus 1, and that's a minus 2. The best part that happened here, that is all Cj minus Zj's are less than or equal to 0, as all Cj minus Zj less than or equal to 0. So stop iteration. Stop iterations. Stop iterations. Okay. As we stop the iterations, we get the final answer here that best solution is available here. And that what is the best solution? It is assumed, not assumed actually, there is a rule for that. Generally, the basis variable, this basis variable takes the entire value. What is the basis variable? That takes entire value of this bj, and non-basis variables are always 0. So this is the rule you should remember. Basis variable takes entire value of a bj in any table, in any iteration there, and non-basis variables are 0, and that gives us a maximum value of a z. So in this case, the basis variable is x1. Therefore, this x1 should be 100, because this x1 should take entire value of a bj. And non-basis variable, the non-basis variables are like x2 and s1. So this x2 is a 0, s1 is also 0, and this indicates x1 100, x2 0. What is the value of z? Because z is a 2x1 plus 3x2. Therefore z is 2x1 plus 3x2, that is a 200. 200 is a maximum value of z. Is a maximum. That about end of the question here. This way you should finish in the exam. But let I come to the previous tables, and I will tell you few of the things that happened there. So if you observe in previous iteration, if you come across this table, the previous iteration, the basis variable we said as x2, it always takes the entire value of a bj. So in this table, actually actually the value of x2 is a 50, x2 is a 50, but x1 and s1 are non-basis variable. They are not in the basis. So x1 should be 0, and that s1 is also 0. And what is the value of z? If you compare here, 2x1 plus 3x2, this is 150. So this table we have the value of z as 150 there. But Cj minus z's are positive, and because of that we move to the better solution there. Like that only, if you come to the first table, in the first table, initial table, the basis variable is s1. It takes the entire value of a bj. In initial table, that s1 is 100. S1 is 100, and non-basis variable are x1 and x2. So x1 is a 0, x2 is a 0, and what is the value of z? The value of z is a 0 there. So in the initial table, we have x1, x2, 0, z is a 0. Okay, that is initial table. Next table, we have that is x1, 0, x2, 50, that is 150. And third table, we have 100, 0, and 200. And exactly same thing you will observe in a graphical form. In the graphical form, you have this initial table when x1, x2, 0, z is a 0. Then the first iteration where x1 0, x2 50, 150, and second iteration where x1 is 100 and x2 is a 0 and z is a 200. And thus we reach to the maximum value by moving from corner to the corner of the feasible region. So initial table we made for origin. Next, actually we reach to the point B there, and then we reach to the point, sorry, I think we reach from to the, yes, point B, and then we reach to the point A, and we get a maximum value of a z as a 200 here by the simplex method there. So what are the important things where you should focus there? The first thing, whatever the LPP you are given, write it in the standard form by adding the slack variable only. Okay, so you have to add s1, s2, s3 for less than type constraint only. Then the table starts with the Cj values. They are the cost values of the objective function. They are here. These are Cj's are 230, 230 are Cj. Then corresponding variable x1, x2, s1, and bj we return. So this is x1, x2, s1, bj. The constant is written below it. After that, the inner product you have to calculate zj with the dot products there, like 0 into 1, 0 into 2, 0 into 1, that's one zj. And lastly, cj minus zj is an important row which decides whether there is a chance to improve our solution or not. If some positive value exists, there is a better solution available, and we go for that by taking that as an incoming variable. So as maximum positive value is a 3, we taken that as the incoming. Then minimum positive ratio is outgoing, and we repeat, make a pivot as 1 by elementary row operation, and we repeat this process till we get all Cj minus Zj less than or equal to 0 there. Okay, so that about the method here we have.